Hey everybody, this is Mr. Longo, and this video is going to cover independent, dependent, and conditional probability. So, independent events, that's when the occurrence of one event does not affect the occurrence of another event. But dependent does, where the first occurrence changes the outcome of the next event. And conditional probability is the probability of an event B given that A has already happened. So we have a couple of formulas. If the two different events are independent, then the probability of A and B happening is just the probability of A times the probability of B. But if it's a dependent probability, it's the probability of A times the probability of B given that event A has already happened. So I know it sounds confusing, but once we start doing an example, it'll make perfect sense to you. So check it out. You have a bag containing 20 marbles, and you have 10 blue, you have 6 purple, 3 pink, and 1 green. So we're going to have to determine if these are independent or dependent occurrences, and then we're going to calculate the probability. So check this out. What is the probability that you select a blue marble on your first try, put the marble back into the bag, and then go select a green marble on your second try? This is independent. And the reason why is the first is you're going to select a blue, which is 10 out of 20. But then you're going to put it back in the bag, and now you still have 20 marbles in the bag. So what's the probability that you're going to select a green marble on your second try? Well, that's just 1 green marble out of 20 marbles. So once you multiply those together, you're going to end up with 10 out of 400, which is 1/4, or 0.025, or 2.5%. So there's only a 2.5% of that happening, okay? But they're independent. The next example says, what's the probability that you select a purple marble on your first try, then set it aside, and then you select a pink marble on your second try? So this is dependent, okay? This first one was independent, this one is dependent. And here's why. The first try, you have 6 out of 20 marbles. But once you put it aside, you no longer have 20 marbles in the bag. You now only have 19. So you have 3 pink marbles still in the bag, but you're only selecting out of 19 marbles. Okay, so that changes the probability. So those are now dependent. So this is, there's no fancy notation. All you had to do is take into consideration that the first event has already happened. So now there's only 19 marbles left. Okay? So then you multiply those guys together and you get 18 over 380, which would reduce to 9 over 190, which is equal to 0.047, or 4.7%. Okay, so that's independent versus dependent. Now, there's quite a few other examples, so we'll do one more together, and then I'll let you try the next 3, and we'll see how we do. So what is the probability that you select 2 blue marbles with replacing after the first? So this one is independent because you're going to replace it. So what's the probability of your first blue marble? 10 out of 20. Now you put the blue marble back in, you still have 10 blue marbles in the bag, you still have 20 total marbles, so there's 10 out of 20 again. Okay, so that's 1/2 times 1/2, which is going to be equal to 1/4, which is equal to 0.25, or 25%. Okay, so that's it. So for the next 3 questions, I want you to first decide if it is independent or dependent. Pretty much, if you replace the marble back in, It's an independent event because you're starting with the same number of marbles each time. If you do not replace it, it's going to be a dependent event, which means there's no fancy formula. You just have to think about what's coming next, okay? So go ahead and give it a shot. Click play when you're ready. So what's the probability that you select 2 purple marbles without replacing? Okay, so there are 6 purple marbles. So the first purple marble is 6 out of 20 times. Now you just set the purple marble aside. So there's only 5 left in the bag, and there are only 19 total marbles left in the bag. So that's 30 out of 380, which we know is 3 out of 38, 0.079, or 7.9%. Okay, if you got that, you're good to go. Number 5, what's the probability that you select 2 green marbles without replacing? Well, this was kind of a trick question. There's only 1 green marble out of 20. So once you take it out, there's none left out of the 19. So the probability of that happen is nothing. The probability is 0. It is not possible because there's only 1 green marble. So you can't select 2 if you don't replace. Now, if that was replacing, it would be 1 out of 40 because it would be 1 out of 20 times 1 out of 20. But if you're not replacing it, after you take the one and only green marble out, there's no chance of it happening twice. And the last one, number 6, what's the probability that you select a blue on your first try? So there's 10 blue out of 20. Your second try, you're going to select a purple. So there's 6 purple still in the bag, but there's only 19 marbles total. And on your third try, you get another blue. Well, remember, we already took 1 blue out, so there's only 9 blue left out of only 18 because we already stashed 2 marbles aside. And you'd multiply those and you'd get 540 out of 6,840, which would be 3 out of 38. So 0.079 or 7.9%. Okay, so that's it. That's independent versus dependent. So if they're independent and you're replacing, or it doesn't affect the outcome of the next, you just find the probability of each one and multiply them. If they are dependent on what happens first, you must think about what is left in the bag of marbles. Okay? Now, conditional probability. Conditional probability, again, is what we were just talking about in terms of independent versus dependent. It means something has already happened. So if you have a local pizza place that says that 75% of their customers order pizza when dining in, and the others just order salads or sandwiches, of the customers that actually order pizza, 20% of them order the deep dish. So what's the probability that a random customer that ordered pizza will order deep dish? So that is the probability of pizza and deep dish is divided by just the probability of people that ordered pizza. Okay, and that's because it says a random customer that ordered pizza will order a deep dish pizza. So, I mean, you're not going to order a deep dish sandwich. So this is just the probability of people that order pizza and make sure that it's deep dish divided by the probability that it's pizza. So you would have 20% order deep dish out of the 75% population that orders pizza. And you end up with 0.267, which is equal to 26.7%. Okay? So there's another example almost identical to this. Why don't you go ahead and read it, give it a shot. As soon as you're done, click play and see if you get it right. So 43% of students attended the homecoming football game, but only 23% of the students that went to the game actually went to the dance. So what's the probability that a student who attended the football game also went to the dance? So that's the probability of the game and dance divided by the probability that you went to the game. And you should have 0.23 divided by 0.43, which is equal to 0.535 or 53.5%. Okay? That's that. The last two questions are just testing if it's dependent or independent. So remember, if one does not affect the other, you just multiply them together, and if that's equal, then they're independent because one doesn't affect the other. So if the probability of m is 1/2 and the probability of n is 2/3, if they're independent, then 1/2 times 2/3 would give us 2/6, which we know is 1/3, and that's equal to 1/3. So that's a true statement. So that means they are independent. Remember, the independent formula says the probability of A and B is equal to the probability of A times the probability of B. So this was just m and n. So if the probability of m times the probability of n equals the probability of A, or m and n, then it's independent. So if they were not equal, they would be dependent because that first outcome affected the second one. So why don't you check this one, see if they're dependent or independent. If you said 0.4 times 0.5 is equal to 0.1 and said 0.2 is equal to 0.1 is false, and then that means they are dependent, you are correct. All right, that's it for this video on independent and dependent events. This is Longo and I'm out. See you, bye.